Good morning, everyone. Welcome to this session, both those of you here in the room and also those listening virtually. Thank you for coming to this session. My name is Krista Hazencope from OpenAQ and also Michael Little from NASA. And we're going to be talking a pretty open and broad conversation around the air quality community, various resources that all of us in the room and virtually can offer one another, and better ways to leverage those to advance our work. So briefly, to give you a sense of where the agenda is going, we'll have some, I'll go over some quick session objectives shortly and some general remarks. In figuring out a way to sort of self-organize among the air quality community, we'll be looking at an example of ESIP clusters and the ESIP cluster concept, potentially applying it to air quality. And so Aaron Robinson, the executive director of ESIP, is kindly sharing the what and why around ESIP clusters. We'll be doing some introductions around the room and sharing resources. Mike will be introducing the Analytic Center framework as an organizing concept. We'll then have a pretty open discussion and then wrap it up with what are some next steps we could take, potentially forming an ESIP AQ cluster. So before I get into the session objectives, I was thinking on the way down here, driving from Annapolis, that I'm sure everyone I was passing by was very familiar with NASA in the public. Like, if you said NASA, everyone knows, let alone this room. But OpenAQ, I'd be a little surprised if everyone in the room or virtually has heard of. So to give some context of where OpenAQ and my work fits into this, and also how this ties into our session objectives, I thought I'd give a brief intro. So OpenAQ, we're a small nonprofit based in DC. We work on harmonizing air quality data from various largely government right now sources, and putting it into a single format and then making it available to various users downstream of us. One segment of that are scientists, but it also includes groups like the media, the tech industry, activists, and actually the government as well. And some more specifics of what this actually looks like. So our platform, we have an API that's open where we share this data freely. It's specifically real-time air quality data produced by governments at the ground level, ambient data from stations. So we have about 500 million air quality measurements of these various types that you see down here from various countries across the world, and about 11,000 stations. And so this is a pretty specific data type. And even that data type alone, when harmonized, we receive about 250 million requests to our API per year for this particular data. And again, the whole point of that is that the data is used much more broadly than just for its original use case, but various groups downstream of the data can better leverage that information. So I gave some examples of various buckets that we've seen groups use the data. I thought I'd give two relevant ones to this group from NASA. So one from the GEOS team at Goddard. So they pull in data from the platform from various cities across the world, so that they can take they can compare their model to observations that in real time from the platform, and figure out how they could get insights into their model and potential ways to improve it. Another example from JPL, from the Maya team. They look at data they have looked at data from the OpenAQ platform to help figure out and plan where Maya should eventually focus on, which cities across the world have enough ground monitoring data to mesh with the satellite. And so the larger point of all of this and how this fits into the session objectives is, again, this is a very specific data type of ground monitoring data, again, of real-time government station level data, and even harmonizing that type of data sees quite a broad amount of usage, and really can create an ecosystem and community of shared tools and resources. And in a much broader sense, really the purpose of this session. So to identify not just one bucket, the data bucket of the AIST projects that folks will share out in the room. And then we'll talk about common opportunities and often challenges of working across those various buckets, and ways to potentially find the low-hanging fruit in the room, to overcome them. And a way, again, that might happen is as an ESIP cluster focused on air quality. So with that, I will turn it over to Erin to talk about ESIP clusters.
Thanks so much, Krista and Mike, for the invitation. And actually, this feels a little bit like coming full circle for me, because the way that I got involved in ESIP way back when was as a graduate student working in the then air quality cluster, and helping to build community around that cluster and that work. So I won't bore you with the details. We've seen this slide before, but I think really when we think about clustering, it's bringing together people like Krista was talking about across those buckets and across the data lifecycle around common challenges. And I think when we think about domain-specific clusters like the air quality cluster, I'd say that I think really it's coming together both with a data or a technical problem that you're looking to solve across organizations and institutions and using ESIP as this neutral place to work together, but also that you're working within a context of many other clusters, and I'll share the list of technical topics like schema.org or metadata that are happening within this kind of sphere of ESIP activities that then also lend themselves to being applied to the air quality problem. And so we talk about ESIP as a brain trust. And really we use these kind of coordinating both the goals, the theme, and the values of working together in this open, neutral, collaborative space as a reason why you would come to ESIP to have a cluster. So ESIP brings people together, and these clusters are really what most of ESIP's work is, and we're bringing together organizations and people at this kind of shared infrastructure level. So clusters provide you with a virtual space to work together, to learn from each other, to solve common problems, and to have this kind of exchange. And then you go back to your home institutions, and we actually feel like we're furthering interoperability because the agreements that are reached within clusters then are implemented by our partners. So ESIP doesn't provide data, you all provide data. We don't sustain cyber infrastructure, but I think all of these things that are discussed, and even, you know, in the feedback of standards, OGC is here, as we mentioned in the plenary. And so by working within the air quality cluster, one of the things we saw in the original formulation of that cluster was we were trying to implement OGC standards and ISO standards, and we were trying to get the community to adopt those standards, our community to adopt those standards, and we were giving a lot of feedback into the standards process. So this is the team, and for most of the cluster work, it's actually Megan Carter, who's our community director, who facilitates the cluster activities. And then when you start a cluster, you have access to the suite of technical services. We have a wiki, we have Slack channels and mailing lists. OpenAQ is, I think, one of the best community builders in the air quality space these days. And so these tools are not new. And I think one of the things that is, I think, valuable about how ESIP, being an ESIP cluster, is what I mentioned before of being in the network with these other clustered activities, and being able to see what's going on and having this kind of passive transfer of knowledge because we're using these shared tools. We take 3 approaches. So clusters have in-person events like this session. They then have opportunities for telecons, which, you know, nobody needs another telecon, but I think for thinking about valuable purposes of telecons, of learning from each other, of sharing, it does provide additional bandwidth. And then the ESIP lab is a place where when you're interested in prototyping new technologies that might feed into an AIST project in the future, the lab is really the place that we fund things in the $5,000 to $10,000 level. And there is currently a lab call out. So if, you know, that would be another thing for a cluster to think about, rallying around a lab project or a set of lab projects that might be funded. So that gives a little bit of cover for time and for deliverables. So this gives you a sense of the different kinds of clusters that we have. You can think of the committees more of the kind of threads that run through ESIP, and the ones that are probably most relevant for you all, and those themes are the data stewardship, the information technology, and the semantic technologies threads that then could be reapplied for air quality specific problems. And then the clusters bubble up from the community. So this is the currently active list of clusters. And so they come together, like I mentioned, around common data challenges. They mostly meet in this monthly or bi-weekly set of kind of telecons. Some clusters, though, just come together for training specific activities at the meeting. So cloud computing is one instance where we've seen really successful workshops at ESIP meetings, and they've been fairly dormant during the rest of the year. So you don't have to have telecons if you don't want telecons or webinars. Clusters do produce products, and so the data citation guidelines that were just revised is an example of a product that came out of a cluster. So I think thinking about if there's guidance documents that this group would want to put forward. We've had shared names that have come out of the air quality cluster that have been proposed to CF. And then things like the Tech Dive educational webinars, where really we've just been looking at how to be on the bleeding edge of what's useful and interesting to the ESIP community. So this, when you look back at these slides, you can see a couple more examples of these activities. The Data Management Training Clearinghouse was an instance where we brought together lots of different kinds of training. So thinking about collecting resources across a cluster is a good use of ESIP activity space. And then we do try to figure out how we can have cross-cluster interactions. And we do that primarily through these in-person meetings. And then we have a collaboration area highlights webinar a couple of times a year, twice, sort of in the midpoints between ESIP meetings to help us all see kind of what's going on across the collaboration areas and try to find these points of intersection that we might exploit. So starting a new cluster is really very easy, and you get access to all of the resources that I just mentioned. You email the vice president, who today is Mike Daniels and tomorrow will be Sudhir Surashtra. And then you get access to all of our resources and schedule your telecon and go forward in the world. So I think that's where I will leave it. The thing that's most useful about clusters is when you think about what you're already doing and what part of your regular day job needs community input. And so it's really, ESIP is not a place where like extra work helps. So that's one of the things I would encourage when you think about the agenda and you think about your participation in clusters. It's how is this gonna affect and help your day job? So being selfish is good.
Thanks, Erin. So as you guys have, so as you guys have noticed, one of the major objectives of this meeting is to decide whether or not we have enough interest to start a cluster in air quality and air quality analysis, and to find what that might be. So keep in mind that at the end of this meeting, we're obliged by ESIP, one of our commitments to them letting us use this space to do this, is to come up with, I think it's three lessons learned or 3 ideas or 3 things that we want to carry forward with. And one of those ought to be whether or not there's enough interest to start a cluster in this particular area. So I know a lot of the people in the room, but I won't say that I certainly don't know everybody in the room. So we're going to, the next step will be to go around the room and provide a brief introduction. And if there's a slide. Yeah. To you. Okay, so we're going to
start by going around the room and I'll just briefly identify myself. I'm Mike Little. I work at NASA and have for longer than most of you want to remember. I work in the Earth Science Technology Office. I, up until yesterday, was the AIST program manager. Jacqueline Lemoyne, who I will ask to introduce herself next, is now the AIST program manager, and I'm going to wander off and find other technology things to do in the agency. AIST has been funding a lot of work to do analytic center framework analysis, and I'll talk a little bit more about that in a few minutes. But my interest in air quality, in particular, both personally as well as from an AIST program up until yesterday, is that we think there's a lot of synergy. Think that air quality has a huge impact on America today, and that we need to try and pull together the resources that are available to help people who need to make decisions about air quality and understand what's going on, be able to take advantage of those resources. So with that, I'll ask Jacqueline to introduce herself next.
Okay, so I am Jacqueline Lemoyne. As Mike said, I am since yesterday the AIST program manager. Up to yesterday, I was the deputy for one of the two thrusts, which is a new observing strategies thrust, which is very similar to something like sensor waves. And air quality can be one of the use cases of this kind of new observing strategies. My background is in computer vision image processing, artificial intelligence, and distributed spacecraft missions and high performance.
Hi, I'm Gina Holm. I'm with the City of Los Angeles. I serve as the chief technologist there. I recently was a recipient, along with Krista and a few others, of an AIST grant on predicting what we breathe, looking at air quality and predictive analytics and machine learning and modeling. My background is I spent 32 years at NASA, so maybe almost as long as Mike, but not quite as long as Mike.
Nobody as long as me. Werner von Braun isn't around anymore, so.
And sort of the architect for data development at the national level. And so my particular focus right now is on the application, so not just machine learning and analytics, but the application of that into city policies and processes, not just for Los Angeles, which is one of our biggest air quality challenges in the country, but also for other mega cities.
Thanks. I'm Karen Petraska. I'm from NASA. I work in the CIO office, and I'm responsible for making cloud computing available to the people at NASA.
Good morning. My name is Ian Brosnan. I'm the deputy for the other thrust of AIST, which is the Analytics and Frameworks. My background is in ocean science.
Good morning. This is Laura Rogers. I'm at NASA Langley. I also work in the ESTO office with Mike and Ian and Jacqueline. I'm primarily within the Analytics and Framework. I'm working in the biodiversity community, the similarities between biodiversity and quality centers.
I'm Jeff Walter. I'm also at NASA Langley in the Atmospheric Science Data Center. I'm the deputy manager and also the lead system engineer there. With respect to, and I've been at NASA Earth Science in some capacity or other for about 21 years. With respect to air quality related work, so at ASTC, we are having to distribute a lot of data sets to scientists and do some processing. A lot of those data sets are related to air quality, both existing missions and some upcoming missions as well. We'll be supporting particularly mine in Tempo. We'll talk about that later.
We'll talk about that later.
Okay. Yeah. So yeah.
Good afternoon. My name is Jason Barnett. I support several different geospatial efforts out of NASA Langley Research Center, specifically at the Atmospheric Science Data Center. And most of my capabilities is all things GIS. So.
I'm Phil Young from George Mason, where we have a research spatial temporal innovation center. My research has been focusing on computing tools for processing data like qualitative prediction, machine learning, data sets, including data sets that have done about 2 minutes into what we did today.
Dan Duffy, so I'm at NASA Goddard. I am in charge of the high-end IT for science at NASA Goddard. High-performance computing, scientific visualization, large data, and the Analytic Center framework fits right in.
Hi, I'm Sudhir Shrestha. I'm with Esri, and I'm a lead tech POC point of contact for NASA, NOAA, and USGS. And my background is in geospatial science domain and as well as heterogeneous modeling.
Charles Carlton with the National Centers for Environmental Information. I work for the data access branch. My main duties involve making sure that gridded data for large data sets is available to the public, and we also have features like graphing to sum up them. We are hosting the NDGD, which is the National Digital Guidance Database Archive, and that data contains air quality data. That data is basically the data that the weather forecasters use to produce their forecasts.
Thomas Fong from JPL. I'm a technical group supervisor and manage a group called the Computer Science for Data Intensive Applications. So we mainly focus on big data processing and analysis. I'm also the recipient of several AST projects over the past year, thanks to Mike and Jessica. And currently, I'm also co-write on the recently funded project for mapping. The PI is right before.
Hi there, I'm Beth Huffer. I am the owner of a small technology company, and we provide contract support for the Atmospheric Science Data Center that Jeff Walter just mentioned. I'm also the PI on an AIST project that is trying to develop automated methods for providing semantically rich metadata for variable level metadata for individual data sets.
Good morning, my name is Shayna Skolnick. I wear multiple hats. I'm the founder of a small technology company called Napteka, doing mostly emerging technology and innovations that covers cloud, virtual augmented reality, social AI, and recently voice applications, which is custom Alexa. And then I also lead a project with NASA, like the headquarters of Applied Sciences Group, disaster applications, using immersive technology like VR and AR to look at GIS and disaster-specific data. And we've actually done some visualization of the air quality data, which is interesting because it's something that's very difficult to see. So I look forward to learning more about these data.
Hello, my name is Irina Gerasimov. I work at NASA Coding Data Archive Center, and my current interests lie in machine learning tools to help our users to navigate.
Hello, my name is Jennifer Wei. I'm the lead scientist at the Goddard Data Center. My background is atmospheric chemist, especially from the model, from the satellite retrieval. But my primary interest is to how do I better to combine or bring out the NASA Earth science observation information through the data and services, allowing the application users or users who are appropriate to utilize the NASA Earth observatory data.
Hi, my name is Angela Lee. I'm the lead engineer for Justice, and my background is software engineering, and my focus is building better tools and service to serve the community.
Just in case you haven't heard enough from us, I am also, with the Goddard Earth Science Data and Information Services, I'm the manager there, and we have a wide range of products that.
Say your name for the people who don't know you. Yeah. There may be somebody in the room who doesn't know you.
Oh, I think there's a lot of folks out there for the first time. So we have a wide range of observation and model data that are relevant to the air quality community, aerosols, atmospheric chemistry, and we have a number of technologies we think are relative to the analytic platform, some of which have been developed historically.
Hi everyone, my name is Rahul Kumar. I'm a data engineer with Element 84. We are a contractor on NASA's EED2 program. I feel like I'm an exception in this room. I actually don't do any air quality related work, but I'm just most here because of my interest in the subject. I just wanted to come and see what people are doing and learn something from it. Thank you.
Hello, everyone. I'm Tom Rock. I'm from Dr. College in Baltimore. Part of our undergraduate data science program, we have an introductory course where students are going to go out on campus and collect air quality measurements. And so I'm very interested in learning about what other open data sets and resources are available that we can leverage for educational purposes and hopefully build out some of our semester-long projects.
I'm John Custer. I'm the manager of the Atmospheric Science Data Center. And like Jeff said, we archive, distribute, and process a lot of air quality data.
Hi, I'm Brendan McAndrew. I'm the Applied Sciences Coordinator at Goddard's Applied Science Office. We have a pretty broad scope. One of our activities is an air quality and health working group that meets monthly to discuss applications of air quality, the challenges faced working with end users, partnering both within NASA and also just to understand what end users actually need in terms of data accessibility and usability.
Hello, this is Yaxin Wei from Oak Ridge National Lab, Distributed Active Archive Center. I'm the acting lead scientist there. I have a background of geoinformatics and terrestrial ecosystem modeling. And my interest is to ensure the data sources and services currently we have, and also potentially we will have in the future to fulfill the needs of the community to do scientific discovery like air quality research.
Eugene Yu from Georgia Mason University. Not a background in air quality, but I'm interested in stuff because mostly focus on GIS and process.
Yeah, I'm Steve Olding from NASA's Neuroscience Data Systems Working Group, so interested in all aspects of data systems for NASA's Earth observation data.
Hi, I'm Elizabeth Goldbach. I'm a science writer with NASA ESTO, so I'm the tech lead and everyone else here from ESTO, and I'm looking for new stories to highlight for our website.
Hi, my name is Alice Premium. I'm a software engineer at JPL. I work with Thomas Wong. I work mostly on Pew DARPA, like large-scale ML projects, and I also work on the science data analytics platform at JPL.
Hi, good morning. I'm Vinita Casey. I'm also from Data Center at Goddard. And mostly I'm looking at the GIS services at Goddard. And my background is mostly looking at the impacts of extreme events and obviously the impact from the air quality. And I would be mostly interested to learn about what services you have and what you are planning to provide, and I look forward for collaborations. Thank you.
I'm Sarah Graves. I'm with the University of Alabama in Huntsville. We have a rather broad portfolio. I'm a computer science professor, but I also head up a research center, Information Technology Systems Center. We, in collaboration with Marshall, operate the Global Hydrology Resource Center. So that, of course, covers a lot of different types of data and variations. So we've focused a lot on not just the accessibility of the data, but the usability of the data, tools and things of that sort. And we also do a lot of work with the defense world and NGA and some other entities. Many of them have concerns with air quality as well as other types of data. I think another aspect is the Gulf of Mexico. We do a lot of work with that world with regard to variations on atmospheric quality and data or air quality of data.
Hi, I'm Marge Cole. I'm a deputy manager with the AIST program. I work with Mike and Chick Lee and everyone else here from the AIST. My background is in information systems and technology development for NASA's missions and data systems. And I've been with NASA about 20 years.
Hi, I'm Jennifer Cruz from the Jet Propulsion Laboratory. I actually work in the Earth Science Laboratory there. I'm leading the Office of Integrated Earth Mission Systems, and this is actually a pretty unique office because of the fact I'm leading some development projects such as Restart SWAT, Sentinel-6, so that's pretty exciting. But the other part of it is really infusing current technologies and really on-ramping them early on the projects that we can actually do in the future. Because I think the work that this community is doing is fantastic, and yet we need to get it a little bit more information.
My name is Manil Maski. I'm currently in detail at NASA headquarters in the Science Data Systems program. My background is computer science, machine learning to be specific. I'm interested in how the data system can support this 19th century framework for
Hi, I'm Hook Hua from JPL. I think I recognize some of the faces here. My background's in science data systems. Some of the projects that I PI'd in the past have focused a lot around multi-sensor data system analysis with machine learning in the cloud. And I think some of the background that we've worked on focused on doing multi-sensor SAR with A-Train data fusion for things like from disaster response all the way up to cloud classification for atmospheric composition. And on the side, the systems architect for the NiSAR swap mission that Jennifer mentioned.
I'm Karen Moe, and retired from NASA Goddard a few years ago. But the last 20 years of my experience at NASA was with the AIST program. And I was really very fond of the sensor web work that went on there. And I'm currently in my hometown. We are putting together an air quality monitoring system on the ground because of some issues with industry that is next to the town and roads and the like. So we're doing that work with the University of Maryland. And so I just thought there might be something here that can help us with that little project.
Hi, I'm Helen Conover, also with the University of Alabama in Huntsville. I work in Sarah's group. And I'm just wrapping up an AIST project that was building a data framework. And the primary focus was on 3D interactive visualization. And I'm going to be helping with a follow-on project that shifts the focus to machine learning.
Arif Al-Bayrak, I'm from NASA Goddard Data Center with a background in applied math, and I'm looking into the especially data sets with application to the machine learning area and how to draw the future vectors and so on. So
hello, my name is Justin Rice. I'm from the NASA Aeroscience Data Information Systems Project. We ingest, archive, distribute, and manage many different types of discipline-specific data sets. Their quality is one.
Okay. Yeah.
Hi everyone, I'm Ellie Davis. I'm one of the community fellows at ESIP, and I am a PhD student at the University of South Carolina, where I study the impacts on coastal communities of sea level rise and hurricanes. And my interest in air quality is I actually worked with COCRAs and a bunch of very enthusiastic retirees who were interested in doing air quality monitoring in their backyards. And so I was wrangling that and sending them to different resources.
So do you guys want to, since you've already talked, do you want to introduce yourselves? Okay. Okay, so I'm going to take a few minutes. Is there anybody who hasn't heard me go on and on and on about analytic center frameworks and things like that? Okay. Okay, so I have an opening to talk for a few minutes. Anyway, one of the things that we've evolved over time in the AIST program is this idea of an analytic center framework. It's, if you think of it as sort of a way to get at a capability for doing the analysis of data in order to support a scientific investigation. It harmonizes the data, the tools, and the computational resources to permit the research community to actually move ahead with their investigations. It's not intended to compete with the DACs, although in some cases, for example, one of the projects that Thomas Wong has worked on, they've implemented an analytics center framework at the physical oceanography DAC and done it really quite well, and demonstrated the value of this in that particular community. So I'm not going to spend a lot of time on the concepts, but just so that we have a framework that we can start talking about related to air quality. Let's see, so this is sort of my block diagram, and as people in ESTO will tell you, I'm really bad with graphics. They just look like reorganized bullet charts. So you can see what that means. In this particular case, what I'm trying to depict is an environment in which the tools, the data, and the computational infrastructure is made available to the science investigator who has a specific investigation that they want to conduct. In some cases, it's the kind of thing where they stand it up, they use it, and then they throw it away and or put it back on the shelf would be maybe a better way of describing that. And in some cases, they have long-standing, repetitive investigations that are going on, such as at the Physical Oceanography DAC. Thomas has constructed a system in which people could come in and the data and the tools are available for reuse, making it pretty easy to stand up their a new investigation and actually get started working on it rather than spending all their time trying to figure out what's available that they might be able to use. So since we're going to talk about air quality, I stuck together a sort of analytic center framework view like the last one that identifies the data, the tools, and the computational infrastructures that are available. And I did this intentionally as a hand-drawn pencil version so that you didn't think that this is the answer. This is just a notion for us to start describing. What we're going to do in the next few minutes is we've invited some people, Krista and I have invited some people to speak a little bit longer, sort of an expanded introduction in the areas that we've identified previously as sources of data or computational technology environments or tool makers who have things which we think are potentially useful in this environment. And I did it in pencil and a piece of paper and then took a picture of it with my iPhone just to prove that I actually can do technology from all ends of the spectrum. So I tried to make a list over on the left-hand side of some of the characteristics. Krista's chart earlier was actually much better about describing what are the fundamental parameters that we're interested in air quality. And then I've talked about some of the data sources on here and some of the tools and the AIST projects in particular that apply to some of those areas and how they relate. There are, let me just talk for a second. There are about 5 AIST projects in the AIST 18 solicitation that relate in some way to air quality. 4 of them are specifically related to either analytic center frameworks or to models that are being updated or modernized. And one of them relates to some general purpose capabilities in using new data sources where you want to create metadata that looks a lot like what you're already using so that you don't end up with all these different sources of metadata that then don't necessarily make sense. So I want to just mention 2 examples of analytic center frameworks that are already in existence. One of them is at the Physical Oceanography DAC that I've mentioned that Thomas worked on. The other one is the NASA Earth Exchange at Ames, which is run by Raman Namani, and it's accessible to the public, and it runs models that run on the supercomputing facility there. There are 5 or 6 others, and I put them in the backup slides, but not to beat the point to death. There are people who are already doing this kind of stuff, and as you can imagine, those of you who know me, I didn't come up with these ideas originally. Somebody else came up with the various pieces, and I just sort of stitched them together. So what we're going to do is talk a little bit for the next few minutes about some of the AIST projects that are relevant to this. One in particular, Gene's going to talk for a few minutes about the City of Los Angeles work that's going on. And then I've asked certain people to spend sort of 2 minutes talking about what they're doing right now. And then we'll open it up to let other people talk about things that they want to expand on just to make sure that they get visibility or relevance. And then we're going to we want to devote most of the remaining part of the session to a discussion. And in particular, what we want to understand at the end of this is, does it make sense for us to stand up an ESIP cluster and try and have a community, multi-organizational community that works diligently at trying to improve the way we can understand air quality. And so with that, I'm going to turn it over to Jean Holm and let her talk about predicting what we breathe.
So huge shout out to Krista and also Mohammed Pour Mohamian at Cal State LA, who's one of our other research partners, and the great folks at JPL and ESIP for providing the focus last year at a workshop that helped to lead to this proposal. So the idea really is to look at some of the AIST issues around closing the gap between the ability to gather the data and the ability to actually use the data. And so the city of Los Angeles is not your typical ESIP partner, perhaps, but I think it's really important to have local governments and regional governments as part of the partnership within ESIP. And we heard a little bit about that this morning with public-private partnerships, because really the idea is, when we're trying to make use of NASA data, and particularly around air quality, what better place than the organizations which are actually implementing interventions in air quality. So we all know that planting trees is good for air quality, but when we think about all of the interventions that a city can do, and a city with a budget of $9 billion, 4 million people and 500,000 businesses in Los Angeles, it's really a huge opportunity for impact. So the key questions that we're trying to answer with this, and it may seem grandiose for a technology project, but really we're trying to use the application of machine learning to these vast data sets, both the satellite data that we'll be gathering from OpenAQ and a lot of other missions, but also ground data sensors. So we're using citizen science data sensors with smart air inhalers that have GPS location devices on our air inhalers. So we're using school kids are part of our citizen science community, and also the Southern California Asthma Association, as well as Anthem Blue Cross for the health outcomes that we're looking at. And then also using Internet of Things sensors across the city. From that, we'll actually start to do both analytics about historical interventions. So if we planted trees 20 years ago, what's the impact in that environment, in that neighborhood right now? But also more importantly, like, what are some of the policy interventions and how can we change the way in which we inspect sites and look at the aspects that are having negative issues. One of the biggest problems we had recently was a huge methane gas leak at one of our in one of our neighborhoods in Los Angeles that went on for 9 months. And so trying to understand how we can change both like things around methane gas and particulate matter. So the idea is to create more visualizations and identify that local data and integrate that local data to look at the gaps in coverage and really correlate those to our interventions. And then part of this is to work with other cities across the planet. So Mayor Eric Garcetti is the mayor of Los Angeles. He was recently, 2 weeks ago, elected to lead the C40 cities, so the top 40 climate cities organization. And so we have a lot of impact and ability to connect with cities through 100 resilient cities, through the C40 and others, through global cities across the world. And then we also use the Sustainable Development Goals, the UN SDGs, as part of our framework for how we do things in Los Angeles. And so that connects us to a whole nother network of cities through the UN. So some of the tools that we're using are typical AIST and earth science tools, and the data that we're getting back from MODIS particularly, but also a variety of other things. And then also both citizen science tools, in our own city-controlled Internet of Things sensors from traffic, sensors on our street lights and street poles, and particularly the Port of Los Angeles. So the Port of Los Angeles is the busiest port in the Western Hemisphere, and 40% of all imports to the US, all imports come through the Port of Los Angeles. And each of those boats pollutes through air quality pollutants as much as 167,000 cars. So given that we're the busiest port, the impact of air quality issues in those neighborhoods, particularly around the port, are huge. And then when you think about the amount of traffic that comes out of that and trucks, that is why the air quality in Los Angeles is considered the worst in the country, and why we are ground zero for making an impact by using better NASA satellite data. We're using a variety of tools. Shout out to Esri, who's a huge partner for us in Los Angeles, and working with EOS, of course, And then we have a data analytics platform that we use with Jupyter Notebooks and Tableau and a variety of other things. And then we'll be using the other analytics platform, and everything gets published for us in GitHub. We have a data science federation that connects 18 local universities in California and Arizona with our data science challenges. And so we have a huge reach out to university professors and students across those different universities to be able to help with that. We're using a variety of models to start this work, and then really the metrics with a particular focus on particulate matter 2.5, but really looking across that to see what we can start to do in analyzing this data. So we're continuing to look for partners. We're just starting at the end of February with this program. And so we already have spoken to Phil Yang, so thank you very much for the great work you've been doing with urban heat. And some of the models actually cross pretty well across from different areas into air quality as well. So thanks.
Okay. So do we load Sudhir's slide? Sorry to thank you. So Sudhir, if you want to come up. The next person I asked to talk was Sudhir to talk about what Esri is doing in terms of air quality and what resources are available.
You number 5.
Thank you, Krista. Thank you, Mike. So I have 2 minutes. What I'll be talking about, so again, I'm no expert in the air quality, but I'll be talking about some of the technologies that we use. So this is something we looked at. One of my colleagues, Kevin Butler, is working with some of the CDAC data, looking at the quantifying the spatial, temporal pattern from the CDAC data, and I definitely would like to acknowledge the CDAC for the data they provided. So looking at the data from 98 to 2016, but among that, we have a tool that we call spatial temporal data mining tool. So this is something new that we just coming up on 2.5 that we're supporting. But what you're doing is basically you are creating a space-time cube from multidimensional data. Before we used to support the point data as well, but this is something we have new capabilities that we can support using the raster data as well, right? So basically, what this tool is helps you to sort of like identify the trends by clustering points as well. But we just added, like I said, like space-time cube for multi-dimensional raster data as well. So what you're doing is like basically you're analyzing the data through the time, and then you basically put all the data into the space and time bins, right? So it's easier to do the analysis. So just to show you quickly what I looked at was some of the air quality, some of the PM 2.5 trend you see here in Nepal. I'm originally from Nepal, so I just thought maybe I'll give it a try to look at the quick the 2.5 impact looking CDAC data. So you see like there's overall PM 2.5 concentrations are increasing in the central region of the eastern region of Nepal, and also going to the China, right, during that period of time. And similar analysis that you can do as well, like you can look at if there's any pattern changing or not, right? You can look at here, like in the here, if you can see or not, but like here in this region, there is like a new hotspots developing for the PM 2.5, right? So there is a sort of like an increase in the PM 2.5 concentration that increasing in that part of the component. But what I'm trying to show here is like we have the capabilities within the tools that you can use very efficiently with some of your multi-dimension data to the space-time mining with the air quality data. But air quality data is in one example. You can use other data as well. And I'll be happy to talk to you more in detail. I'll be here today and tomorrow. Thank you, Mike.
So while she's bringing that up, I just want to mention one other project that we have been funding at ESCO is is the use is at University of Maryland in Baltimore County. And thank you. So one other project that we've been funding at the University of Maryland, Baltimore County is to use machine learning in conjunction with ceilometers, which are ground-based LiDARs that are used in our airports to try and assess the planetary boundary layer. As you know, those of you who work in air quality, planetary boundary layer determines the density of the pollution, because at night when the layer goes at lower altitudes, it compresses the pollution, and when it warms up and expands that layer of the atmosphere, it dilutes the pollution because it's spread at a much higher altitude. So that's another project that that's ongoing right now to help with air quality. So go ahead.
Well, thank you, Mike. So give me about 2 minutes. I'm trying to put things together and also chop down a lot of details. That's why you see only my name here, but this is really a collaborative work from a lot of people. This one shows the computing, communication, and information stack that we have been hands-on in the past few years to a decade now. The bottom 2 layers are the computing side, which we have been working intensively with Dan Duffy here in the room, and also with Thomas. We started the cloud computing cluster at ESIP. And on top of that, in the middle layer is the big data. So that there's a container tester that we did a few years ago, also with Thomas and others from JPL Ames Research Center, on how these tools handles the big data sets. And on top of that, as a machine learning tools, especially open source technologies, which could help us to managing the observations and using the downscaling, upscaling of data sets so that we can collocate in spatial temporally the data sets, including air quality and temperature, precipitation and others, and also simulation prediction using machine learning and detection of the results. So the data sets we have been hands-on. I put together all the data sets we have hands-on in the past, which includes climate data sets, for example, MERA2, and some in situ IoT data sets. As you see from the list, the range from the past decades of data sets from hourly minutes to about annual data sets. And I'll jump through this because I think everyone probably knows some of these data sets. So these are some of the results we did in the past. If you look at the left side, which is to do using machine learning, 3 different types: farm, dictionary-based, ground truth, and this is collaboration with Dan Duffy about collocating different data sets from the high resolution to the low resolution, or from the low resolution to the high resolution. That's on the left. On the top part, we pick the which is a JAXA Hawaii, the AHI instrument, to find out what is the retrieval aerosol optical depth data, which is closely related to PM2.5 and PM10. That was in fact 2015 data sets when the air pollution is doing a big issue in Southern Asia, and you see the results on the top. And on the bottom part is the one that Jim mentioned, that the temperature data sets, which is close to air quality, and how that has been. We did the interpolation, which is also trying to collocating spatial temporally collocating the data sets for the setting range. So these are the results, and we did have some tools and some experiences to share with us, and hopefully we can engage this in the cluster. Thank you.
Thank you. Dave Meyer, would you mind talking for just a few minutes about Giovanni and about the data sets that are available?
So I figured it'd take me longer to load a slide set than to actually just talk to it. So I'm with the Goddard Earth Science Data Information Services Center. We have a large number of atmospheric hydrology and climate-related data sets. Many of which are related here. Some of them are model-derived, such as the MERA data sets. Many of them are observation platforms, such as the sounders, the AIRS, JPSS suite of sounders. Some of them have more of a chemistry focus, OMI, TROPOMI, if you're familiar with the ozone monitoring, that also pulls out other species, such as formaldehyde, the NO2s, SO2s, and related things. Giovanni is a I'm going to call it a platform, that's been around for pushing 20 years right now, and it's you get access to roughly 2,000 different variables, and I would say a very large number of them would be relevant to this community. Some of them have been discussed already. You can do up to 22 different visualizations, slicing things through space, through time, vertical profiles and the like. And we also house data not only from our own data center, but also data that comes from some of the other centers, such as ASDC, such as Modus data, and other things. So we've integrated data from a number of different sources. We are currently in the process of moving into the cloud, using Amazon Web Services. Right now we're trying to set it up such that the way it stands right now, we either consume things for Giovanni from other data centers, such as through OpenDAP, and then bring them into a scrubbed cache, which means we have to clean it up a little bit. We're trying to set up this cloud environment such that we don't have to appear to curate other people's data. So we're going to do some collaborations this year, primarily with the Modus Veers group, but we'll be looking to extend that with some others. And that's going to help us understand some things like, how do you actually curate data sets if you're spinning off, like say, cloud optimized data stores? How do you work that into sort of like a provenance model for tracking things back to sources? And those are things that we'll probably have a lot more to say about as the year unfolds. So,
thank you very much. Thomas Wong, would you mind talking for a few minutes about what you guys have done?
Okay, so my name is Thomas Huang, and you're gonna help me fix something. So I was told to keep it short, so lucky for you, because I could easily be up here for an hour. So
you get around lunch.
Yeah, that's not usually not a good sign. So again, I worked at the JPL. Instead of talking about years, how long, but I just tell you that I started my career working, developing system for the Galileo missions and the Mars Pathfinder. So do your math. Let's see, come back to this. Mike's already give you an introduction of what ACF is, and the idea, this is kind of a little bit more detail about how the flow of information, pulling data from observation to model, and how you create a harmonized environment where you can easily doing comparison, analysis, and visualize the data interactively. Is still not working? Stop the clock. Okay, so how do I close this thing? Which one? This guy? Let's throw this away. This is okay. All right. So our goal is actually looking at not just open sourcing. This is actually technology I'm talking about is all open source technology, but we really focus on professional open source. So there's a lot of people throwing software out there and say, hey, it's in the GitHub. We really don't want to just say, here's a GitHub and go figure out what to do with it. It's really, we want to create a turnkey solution for you. The technology is not just really nicely graphic, which is I love, but it's also create a platform where you can actually allow the scientist and researcher to interact with the system using something like Python or IDL or MATLAB or C++ or even Fortran, and interact with the data without having to download the data. So we have a project over in all this technology that Mike and the ESTO program have funded called the Ocean Work. Now it's actually under Apache Foundation. It's called the Science Data Analytic Platform. And it's not just for analysis, it's actually got a growing collection of capabilities. It does things like interactive analysis for satellite observation, but you can do things like matchup for in situ to satellite data, and can do things like search relevancy with Phil Yang's team. We develop things like a container deployments, building big data solutions, not just for, just here's a piece of software, go figure it out, but how do you turnkey and get it up and running on the cloud or on your own environment. And so this is just a highlight what we have. So since we open sourced this technology in 2017, we established about 6 instances of ACF. Why are we doing that? Is because it's really not practical thing about putting all the data in one place. is just not politically, doesn't make sense, you can't do it. Second is just not cost effective, it's too much data, right? But what happens, you have this instance distribute across the globe. We have an instance that's serving the sea level rise project for NASA. You can talk to the system using just simple API rather than having to download the data. We have the instance that's serving the GRACE data for GRACE follow-ons. We have instance that's serving the reanalysis for ocean states and current. We also obviously we have one running at PODAT, and we are actually putting together this year infusing 2 instances of this system for the CEOS. So this is for the Committee for Earth Observing Satellite. This is international organization. We deploy instance at the Germany in UMASAT. So this is actually opened up ability for us to compare NASA data directly with the ESA data without having us to grab all the data to our own domain. Because the idea here is to be able to call, say, hey, do analysis in this region, can I compare them side by side? I did a screenshot here with the S3 integration. This is actually the latest and greatest, and Alice is the ones actually help make this happen for us. This is the S3 platform. Think about having this system running across the globe. You can actually use the S3 desktop to connect to every one of these and compare the analysis and visualize them without having to download the data. I'm gonna go really quickly. For example, here we actually did this demo from Germany over the ocean. They're talking to 2 different systems. One piece is the data sitting in Amazon. A piece is the system actually running on JPL. We're actually comparing precipitation from the TRIM data and also the river discharge data actually from the JPL. If we can do interactively compare the data over the ocean from Germany over the Wi-Fi network. The system's actually, one of them running in Amazon, the other is running at JPL as a local on-prem system. We was able to analyzing over 3.6 billion data points on the fly. So, so this is just a summary of this. So really, we have a lot of great technology at ESIP, and this is my summary slide. Big data really, I think everybody knows that is, will call for a lot of changes in terms of how we develop systems. As somebody who's been around for so long, I'm more looking at how you're gonna make it into productions. So the projects and the missions are more focusing on, say, great, you can do this in a fraction of a second. How much is it gonna cost me? How am I gonna grow the system over time? How am I gonna sustain this over time? And how am I gonna roll data off or onboard data? These are things that are really all the technology people have to also think about and not just say, well, look at what we can do with Jupyter Notebook. Okay, awesome, but that's just one piece of the puzzle. So finally.
Thanks. Sorry. I always like to give you more time, but we never have enough time with it. So, okay, so Beth Upper, can you talk for just a minute about what you're doing on the AIST project? That's okay. No, it was the slides were an afterthought.
Did I didn't have? Yeah, sorry.
Hi there. So we are working on an AIST project that will use machine learning to try to generate semantically rich metadata. The hypothesis here is that we can describe any data set if we talk about what was measured, what quantifiable property of that thing was measured, and what context it was measured in. And so that's kind of the semantic framework we're using here to try to start classifying data sets in an ontology that is pretty minimal, just with those classes of data sets that have those attributes associated with them. And we want to look at the numerical data and see if the signal from the data itself will allow the data to self-classify along these attributes that we're dealing with. This actually aligns pretty well with what NASA, the ESDIS office, is doing with variable level metadata right now. So the UMM VAR model that they've just come out with is looking at trying to label data sets along those lines also. So we hope that that'll have some nice synergy with that effort. We're working with a group in Spain, the Basque Center for Climate Change, And their team also has members from USGS in Denver that have a network of ecosystem services models. And the idea here is that if we want to provide support for data, science data end users, we need to provide some support for data producers in helping them get the right kind of metadata on their data that can be used by these downstream systems. So the Basque Center for Climate Change has developed this network of models for ecosystem service modeling, and they'll be making use of the metadata that we generate, which will be mapped onto semantically grounded vocabulary from the environment ontology, which is a large ontology that has been under development for a long time, that has lots of vocabulary for describing Earth system phenomena. I will leave it at that. So,
okay, thank you very much, Beth.
Yeah.
The last person I asked to speak was Jeff Walter. And Jeff sort of grimaced when I said that a few minutes ago. Are you still? Sure, absolutely. So Jeff is from the Atmospheric Science Data Center at Langley. I asked him to speak specifically about the air quality assets that were available through that data center.
Can I pop something up on the browser here real quick? Is that the browser? Yeah. So I'm Jeff Walter. Again, at the ASDC, we do we distribute and archive some of the data that fits into the air quality purview. For example, we have Miser, aerosols, Calypso aerosols. We have Sage 3, which is tropospheric composition. But I wanted to talk real briefly about two upcoming missions that we are going to be hosting at ASDC and being the data stewards for that. That I think will be of interest to the air quality community, one of which is Maya. Can't get this browser to do it what I want, so I'll just talk to it for a second. Maya is a mission that's in development at JPL. Maya stands for Multi-Angle Imager for Aerosols. What Maya is going to do is it's going to combine satellite data over specific targets around the globe, where the satellite is going to do a multi-angle aerosol retrieval. And then the aerosol retrievals are going to be combined with surface monitor data from sources like OpenAQ and others, as well as a chemical transport model over each site to create estimates of PM2.5 and PM10, which are then going to be used in epidemiological studies. So some of the folks on the science team are epidemiologists that are going to take the PM10 and the PM2.5 is going to be total, but it's also going to be speciated. What's the actual composition of them? SO2, NO2, black carbon, all the various things, and they're going to try to correlate that with health outcomes, geocoded health outcomes in specific areas. There's going to be level 2 products and level 4, which satellites don't always see everything all the time over any particular area. So at level 4, the data are going to be gap filled and interpolated based on geostatistical models. So, and Maya has a requirement to visit every one of these targets, these sites, 3 times a week. So you're going to get there will be a level 4 product generated 3 times a week over each one of these dozen or so target areas. And it's most of them are the usual suspects. There's LA and Atlanta and Boston, I think, are the ones in the US, and then some of the various ones around the world as well. Maya is going to launch in 2022. So, and the other mission that's also launching in 2022 that I think is applicable to the air quality community is Tempo, which is going to be, it's a geostationary over North America, and it's going to take, it's going to scan from east to west and take measurements of various air quality, species, ozone, aerosols, and nitrogen dioxide, I think, are the main ones over the North American continent. And the nice thing about, again, it's going to be hourly measurements that will be available. And the nice thing about that is it's part of an international constellation of satellites. So the Europeans are launching Sentinel-4, which is going to do Europe and I think the northern part of Africa, and then there's going to be GEMS, which is going to be over East Asia and Indian subcontinent and China and Japan and Korea as well. So those are two things that are coming up. One of the things that we want to focus on between now and then is we haven't engaged directly so much with the air quality community at ASDC, but we're really want to engage more with that community to find out exactly what it is they need or what it is they're looking for with respect to tools or services on these data, especially given the new capabilities of these new instruments. So.
Thanks, Jim. Okay, so those are, I think that's everybody I asked to speak. Is there anybody, I invite our Noah colleague to say, is there anything that you want to add to what you said before about what's available from Noah? Sorry, I'm putting you on the spot, I apologize, but you were a target of opportunity.
Okay, and I'm speaking for NCEI, but I'm also speaking for National Weather Service. Actually, EPA produces this, and it goes through National Weather Service's website. Okay, so the national guidance, the National Digital Guidance Database contains layers of PM 2.5 data that come from the EPA, but they're sort of routed through INSEP and hosted on their server, and they host them for 7 to 14 days as they're used operationally. And NCI loads all that data through a system called AWITS, which ends up making the file names and such cryptic, it makes it a little hard to use. So on our thread server, which I don't have the presentation here, www.ncei.gov/PHREDS. If you go to the main catalog and go to the model page, you go to NDGD, you'll find it, but the file names are quite cryptic. So our thread server is configured to set them up by category and describe things based on what are called WMO headers. I don't know how many of you know about those. And that way you'll be able to get an archive of data going back to 2008, maybe earlier. You just have to kind of tease it out. It's in the grid format. It's generally projected to grids for the United States, so it's continental US. There's the Puerto Rico, Hawaii, Alaska. Now, within a year, our archive should be getting a new variety of this data in forms that are easier, that are common. But those are already available at National Centers for Environmental Information, and it's in their website, and I can't share links because it's in my, and you can get that for recent data. And so there's two sources you can get. So if you're doing a long-term study, you could use that model data, environmental model data from EPA for NCEI. If you need something more recent, you can get it through those services.
Great, Charles, thank you very much, and especially for being a good natured about being victimized in the 11th hour here. We originally had hoped that we would be able to allow people, anybody else who wanted to speak, to talk for a few minutes, a couple of minutes each. But we've kind of run down to, we're now at about 12:15, and we have about 15 minutes left. And the major objective, is there anything you want to say before we? Okay, great. So the major thing that we wanted to resolve by the end of this meeting was whether or not there was enough interest in creating some kind of ESIP-based community that would allow us to collaborate on air quality. As you've heard, there's a lot of data that's available. It comes from a lot of different sources. It's in a lot of different formats. There are some tools that have been developed in the past for use in air quality. There are some that have been developed for use in other areas that may be applicable. So I guess I'd like to open that for discussion and see, does anybody want to jump up and have something that they wrote to say? And then Beth, when you're done, hand it to Jeff.
Yeah, I just wanted to say, the thing that's motivating my particular project right now is that I keep hearing that, you know, one of the difficulties of doing any kind of research, but I think in air quality, this is probably also the case, is that it's hard to work with data. You know, when I go to AGU, I walk around, I talk to scientists, and they say, what, NASA has data? Or they go, oh yeah, I know they have data, but it's really hard to use that data, so I'm not using it, or something like that. And so, you know, I keep hearing that. I think in the plenary talk this morning, that was mentioned that, you know, researchers are spending a lot of time. Somebody here, I think, also mentioned the problem of data fusion. How do you get all the data you need? And I've, you know, heard from scientists that another issue is, well, we know that water vapor, you know, has an impact on extreme precipitation events, but we don't really know exactly how. And so trying to get all that data and bring it together and do the analysis on it requires platforms that make that easier to do. I think researchers are spending like 80% of their time sometimes just doing the data preparation. And so that's, you know, kind of what's motivating me here. And so I just want to put it out there for anybody that's a scientist that, you know, we'd love to hear use cases. And so in that sense, you know, I think this kind of a working group or cluster would be really valuable for those of us trying to develop technology to be to help you do research.
Okay, so I sort of really want to sort of follow up on what Beth just mentioned, because I think we've heard a lot of great tools or technologies from you all, but I'm coming from the science perspective. Now I think Beth touched upon the challenges in finding the right data for the, you know, for the application people to utilize those data to their own needs, right? But from the science perspective, NASA has all this mission and wonderful instruments to observe the, you know, now air quality is a boundary layer, right? With the remote sensing, a lot of information not really, you know, do not provide such an accurate measurement down to the boundary layer. Now that's one of. The other thing is, you know, there are multiple algorithms, you know, from greatest, smartest scientists from NASA people, and which one you would need to apply to your own things. And because we are at the data center, we host a lot of atmospheric quality data from the satellites. Now they mentioned we recently, well, since last year, we host tropo-only, which will provide the greatest information about air quality people. But we also have the NASA model data, which is an ERA 2. And you know, and throughout the tools and services, there are multiple algorithms retrieve the same quantity. And then we have air campaign data from you know, the field campaign from airborne missions. And airborne is a dynamical tracking system. And you know, how do we use the technology to combine those information to bring out the best science information throughout this technology to benefit the air quality people? That's what I'm looking forward to. But I do want to mention you know, the science information from multiple instrument platforms and multiple algorithms retrieving the same quantity. They may give different information. So how can we bring it together? Not to even mention, you know, how do we fuse those information together? So
could you hand it to Sarah behind you, please?
This is sort of a sideways comment, but I think it's applicable. It's more on the AIST program. And so one thing, because many of us have worked with many different NASA programs, and I hope that like as you transition to other worlds, that the AIST program continues being strongly, because a lot of the technologies that are needed very much to address some of the problems, whether it's in air quality or other, in that low TRL, are really sort of migrating from the AIST program into more of the professional sort of a side comment, but I think whether it's addressed toward air quality or other things, that ability to really describe technologies that are applicable to help the scientists is a great contribution from that.
So addressing the issue of data being hard to use, one thing NCEI plans to do is what we call data tour notebooks, which are Jupyter notebooks that are pre-written to get to our data and then allow the users to have some control over some simple examples of how to use it. So these not only allow people to immediately use our data in a useful way, but it also gives them a starter kit for analyzing the data.
So I was just going to say that, I mean, just even in talking at this very brief amount of time today, we're seeing a lot of connections and potential collaboration amongst people. I think it makes a lot of sense to have this as a potential group in order for us to continue that. And really, they come from different perspectives. So there's a lot of tool developers here, and there's a lot of data folks here, and then there's other application folks here. And I think that being able to build off each other, Phil and I met earlier a few months ago, and we'll probably be able to shave a whole TRL level off and accelerate and leapfrog off before he's done on the work that we're going to be doing with AST. But that wouldn't have happened if we hadn't actually had Mike coordinating that connection. And just being able to have all of us have easy access to each other and have this as an opportunity makes a lot of sense.
I just wanted to combine some of these comments together too, and I'm actually looking at this list of questions here with respect to the pain points with data access and whole data wrangling, and then what Jennifer's point about the algorithms. I think these are key things that other activities within NASA that's going on right now. I think there's a lot of things that are applicable here, specifically with respect to a normalization factor that is needed here, meaning that could we address all of these pain points by having specifically ARDs, analysis ready data sets for air quality? If there is this normalization factor where we have a unified or uniform representation of data that handles all of the data wrangling issues and normalizes it into not just a spatial context, but a temporal context, meaning that with data quality, for example, if we're looking at water vapor or humidity mixing ratio, the temporal spacing, say from A-Train, may be 1:30 afternoon observations daily, but then MERA may have early run simulation runs that are 30 minutes, for example. So there's a lot of not just spatial, but there's temporal spacing that needs to be interpolated. That's part of the data wrangling. But if we normalize all that into some form of a data quality, air quality analysis ready data set, it helps us to normalize this representation. Then on the science side, we could have the algorithms be developed that would be applied on this normalized ARD. I think that would help to facilitate a lot of this ACF framework, which is that we can let the community thrive by building a rich set of algorithms that is based on a normalized ARD. At the same time, all the DAX and all the data access issues could be normalized onto this ARD. I view that as one way that we could address this list of questions that you're listening.
So Hook, do you think that this is the kind of thing that would form the basis of a community activity as opposed to an individual project, or how do you see that related to?
Well, most definitely, but I assume that this is just one thing of many things that the community would be working on.
As an example of something. Okay.
I have a quick comment on the possibility. I think it would be beneficial if we can bring in scientists who actually do research on air quality funded by other programs into the discussion that we have here to better capture their needs on the data, on the modeling and the technology aspects. For example, there is currently an ongoing program, project funded by NASA Above program is to assess the impact of climate-driven increase in wildfire emissions on air quality and the health of urban and indigenous populations in Alaska. I think having additional thoughts from different aspects, especially those who conduct science research into our discussion will help us to better capture the community needs.
Okay, thanks. So we have about 2 minutes left, and we have one other thing that we need to discuss, which is the three. Let's see, is there a slide for that? Okay, so three essentially. Yeah, I'm sorry. Yes, I apologize. So there are three things that we need to identify as takeaways from this session. So anybody want to contribute one? Okay, Jean. Oh.
So I think the lesson learned is, based on this last conversation, is that we would recommend developing an ESIP community around air quality and that community framework in order to build off of all of the different collaborations that are happening today to make air quality more accessible, useful, and useful.
Okay. Thanks, Beth. Your turn.
I think maybe this group could recommend that technologists and scientists strive to form a community so that the technology developers can get adequate input from the research community about what they really need in terms of tools and services.
Okay, one last one. And then you guys can go to lunch.
No, it's been discussed already. You know, I mean, we have a lot of cool technology. We have a lot of good data sets. I think just listening to our community and understanding what they're needing rather than trying to prescribe solutions, I think is a pretty important approach. So yes, engaging in new scientists like Beth and Jennifer and others are talking about, I think is probably the most important thing this can do.
Okay. Well, Krista, do you want to say anything before we wrap up?
No, other than to say thanks. So we've recorded a lot of the discussion notes in a file that I believe we shared around with all of you, and appreciate all the comments on how we could be more efficiently working together, given all the different resources we've been hearing about.
Great, thank you. One last assignment before you walk out of the door is if you are not signed up for this session on the ESIP webpage, if you'd identify yourself on there, then we'll distribute the notes and access to the slides and all the rest of this stuff. So thank you all for attending, and I personally appreciate greatly the insight that I've gained as a result of this discussion. So thanks again.